Okay, then over to you, Tony, if you're good to go.
Okay, yeah, thank you. My first thought when I came here was I was going to talk about a lot of things that are on our mind, the end of Moore's law, Dennard scaling, things like that. And but I see that it was well covered yesterday. So then what am I going to talk about? So I decided that, well, we have a lot of assets in terms of pretty pictures. So I'm going to show you a lot of pretty pictures, but I'll try to add some sort of substantive comments behind those pretty pictures and tell a story about the changing compute landscape where we as HP think things are going. And so this might be of interest to you, maybe not. It might spur some conversations during the workshop later today. So with that, see, this is the thing I was supposed to talk about, computing industry challenges. Before I get going, I just joined HP in January of this year. Before that, I was at Qualcomm. While I was at Qualcomm, one of the things I did there was lead a neuromorphic engineering project. We had a quite extensive neuromorphic engineering project, and we looked at every possible reason how a neuromorphic device could be used in a mobile phone, and we weren't able to find any. And I can tell you, it's not that there's something wrong with neuromorphic engineering as a pursuit. It's very interesting. It's just that we felt it was incompatible with the objectives of the mobile phone industry. So I actually changed that whole project over to deep learning, and so it became known as the Zeroth project. So now I've joined HP. I'm working in HP Labs, and I'll give you a little bit of context there. Now, so if we look back in time, this is probably 100 years ago. We had typewriters. These were input devices. They sort of morphed into computers, which looked remarkably like typewriters with a fancy screen. And these morphed into notebooks. And then we have developed the Amazon Echoes that are so ubiquitous now. And of course, smartphones. One thing that all of these devices have in common is that they're rather reactive devices. So you have to actually enter something into these devices to get a response back. You have to initiate things. In the future, it's likely, this is sort of the big theme, is that the world will be more proactive. So computers will change from these reactive devices to more proactive. They'll take care of things for you without you having to ask. See, HP Labs, this is a part of HP. We're a corporate centralized research entity, and we've been chartered with reinventing HP over the last 50 years or so, from transitioning from an instrument company to a printer company to a server and PC company, to a printer company, and now we've taken our printer technology and used it to create 3D manufacturing and 3D printing. And so, we have a little bit of a charter, which is, okay, what's the future? Okay, now go and invent it. And so, so it's often a challenge. Right now we have, there's 4 HP labs currently, print and 3D, immersive experiences, security, which is located in Bristol, and the emerging compute lab, which I head. One of the ways that our CTO tries to communicate our vision at HP is by this process called megatrends, where we look at social and technical trends that are emerging today, which may impact our future. And so I'm going to touch upon use these as a touch point to talk about where we think things are going in the future. So one thing is, but I'm going to put my own spin on things, so I apologize. And the beautiful part about using corporate slides is you can say whatever you want when you're on stage, and you don't have to go through legal review. So one thing is, one emerging trend is rapid urbanization. More and more people are going to move into mega cities. The odd thing about this city is, when I got up this morning, I had breakfast, I checked out at the hotel, I got a taxi over here. All of those required human intervention. So there's a human being behind everything. So today, these massive cities are basically hand-powered. They're like powered by a human crank. They aren't quite automated yet. And so there's a tremendous amount of potential to automate these vast cities. The people who today exist to make this stuff work are not going to be able to afford to live in these urban centers. And so we're going to have to increase productivity in order for us to be able to live in our future. At the same time, we have a changing demographics. So we're going to have a shrinkage in workforce. This again is going to require that we have greater productivity. So we're not going to have as many people doing the things that we need them to do. At the same time, these people are going to become older. They're going to need to be cared for. So there's two futures that are possible: a dystopian future, where or a beautiful future. And this choose which one you want. So it's going to require this will require computation. This will require that we just do nothing. So we have to have advances in computation, new ways of thinking, if we're going to build a future that we want to live in. With a shrinking workforce, we're also going to have to think about how our devices are going to take care of us instead of us taking care of them. We have the emergence of hyper-globalization. People are going to be connected. At HP, in HP Labs, we have sites in India, Brazil, Bristol, Singapore, all around the world. How do we coordinate these workforces of the future? It's likely that some sort of virtual connection between people all around the world, so that they can work together in a collaborative way, is going to become expected. And so how do we enable this sort of instantaneous communication? How do we enable the feeling that you can have a water cooler conversation with a colleague 10,000 miles away? So that has to be enabled by technology, by computing. It's probably going to be critical for our future. Okay, so now this is almost, this is a sort of a cliched expression by now, but Andrew Ng pointed out that AI is the new electricity. So what does that mean? That means that at first it started off as a remarkable technology, something very, something esoteric, but it's moving to the point where it's going to be just a background technology that you plug into. You need to have object recognition. You need to have personal assistance, etc. It might be a metered utility that you get. It'll become boring at some point. But when you unplug yourself from the AI plug, you'll feel the difference. And so our feeling is that AI plus computing are going to be intertwined, and they're going to become just a background for our civilization in the future. Some of the things that, some of the challenges going forward is this idea that you can use artificial intelligence to do things that are specific to individuals. So it's not just recognizing, say, all cats. Recognizing cats in videos is very popular. But it's not recognizing all cats, but a specific cat. So it's not recognizing all possible diseases across all human beings, but being able to tune yourself to particular diseases. So I think there was a speaker yesterday, they were talking about the difficulty of existing AI, in that it requires a huge number of training examples to get anything right. Probably a lot of the interesting use cases, a lot of things that we're going to be interested in the future are only going to have a very small number of examples. And so the technology that we have today isn't really going to be applicable to a lot of the interesting cases of tomorrow. There'll be an increase in personalization. So this is an area which I'm passionate about, and a number of folks at HP are passionate about it as well. It's individualized learning. So I don't know if I'm not sure how the educational system runs in the UK, but in the US, it's based upon your parents' income. So if your parents are wealthy and they can afford to live in a great location, then you'll have a great education. If you are unfortunate enough to choose the wrong parents, then you will have a poor education, and it will be much more difficult for you to enjoy the benefits of society. And so this is fundamentally unfair, and it may be possible that through the intervention of AI, we could have a fundamental change in how children are educated, how people are educated at university, and more than that, we can also think about how AI systems can become symbiotic with human beings, and able to know, to be conscious of what you know, what you don't know, and what you need to know, and be able to guide you in such a way that you can learn faster and more efficiently. So these sort of lifelong companions we don't know how to build them today. We don't know how to build things that are going to be with you all the time. We don't know whether whether this technology will be something that is ubiquitous in the room around you, in the air. There might be cameras every place if you're in certain countries today. That's certainly the situation. Or maybe you carry a device with you that will keep your personal history. But whatever the form factor, it's probably the case that AI will know more about you than your mom does. So that will be both a good and a bad thing, a security risk, and also a possible benefit if used well. So this sort of future can be enabled by new sorts of computing devices that we don't really understand how to build today. We have examples of AI called. This is one of my. This is something that we're doing in my lab. Everyone has had the frustrating experience that something goes wrong with your laptop or your other computing device, and then there's the dreaded, I have to call a customer service agent. So do I gouge my eyes out, or do I make that phone call? Okay, it's a tough decision. So in the future, you can imagine that these customer service agents will know everything about your computing device. So this is an HP laptop. There's a huge amount of data being streamed, taken off this laptop and being analyzed and used. So we'll know about what's wrong with your computer before you even place a phone call. We may know that something's going to fail before you do, and be able to intervene and be able to take steps efficiently. And so instead of you calling a customer service agent, you may get a text message saying, "I think your hard drive is about to go down. We've already sent you one, and so it's on its way." And so that's sort of the future. There's a potential for human AI computing symbiosis. About 40% of us are going to have memory impairment. People who are on AIDS medication for long periods of time have cognitive defects, have cognitive problems, difficulty remembering. So the merging of AI and wet squishy systems is quite interesting. I think there was a talk yesterday about hybrid systems, and I think this might be an example of looking at computers, hard, crunchy computers, and soft things, and creating a better world. Mechanical, cyborgs, of course, are sort of a trope of science fiction, but with 3D printing, you're able to lower the cost of human augmentation greatly. See, before I've been an academic. I've been a professor at different universities, and one of my passions is robotics. And I truly believe that with the rise of AI, plus some fundamental advances in robotics, we will create a new world which will allow us to combat the decay that we may see in the future because of lost productivity and technology trends. And so we shouldn't fear our robotic overlords. We should embrace them, and we should realize that they're going to take over a lot of jobs which we find uninteresting and boring. So when I was a young man just out of college, I had the privilege of spending an afternoon with Buckminster Fuller, if anyone knows who he is. So I was at his house in Pacific Palisades, and he was talking to me about resources and how human beings are able to do more with the resources that they had through society. But then he wanted to point that really the greatest resource that we have in the world is not coal, it's not oil, as my president might think, atomic power, etc. It's the human mind. And so that's the thing that's responsible for innovation. And that's the thing that we keep locked up and suppressed today, because we need people to be our taxi cab drivers, we need people to bus our tables, we need people to check us in at hotels. And those people who are doing all those things are not thinking about the future, not inventing the future. And so if we can replace all that background activity with AI and robotics, we're able to unleash our greatest resource, which is the human mind. So instead of having a dystopian idea about robotics, I have a very positive idea. Except for this guy. This is a night scope patrolling robot. So it's a security guard that goes around. This is an example of a job that can be replaced today by a robot rather well. There was an incident in the Palo Alto shopping mall where it ran over a child's foot, but I think that they'll probably get that bug out soon. There's also this idea of accelerated innovation, and one of the most interesting things is the fusion of matter and computation. And I think we're going to see that along multiple dimensions. You know, we're a printer. We're essentially kind of a printer company right now, but we can print a lot of things, including electronics. And the interesting thing here is that you can embed electronics throughout all products. So it's a matter of getting the cost down. So you can imagine that in the future, each device that you have might have a small embedded computer on board. Okay, so this computer will track where this thing is all the time, from the time it was created until the time it's used in a customer's house. How is that going to change the world? How will that be enabled? If we can print things, this can dramatically lower the packaging costs and allow us to create, put computers every place at very low cost. This is an example of how you might use the 3D printer. So you can 3D print electronics. You can imagine that every item in these boxes has an embedded device. You now use augmented reality to scan through a warehouse, and you can see where how much toilet paper you have, how many diamond rings you have, how many whatever you have, and it will just change the way that we view the world. The world will become active when we're able to embed cheap computation everywhere. 3D printing is another way of merging the digital with matter. So with 3D printing has been around for quite a number of years. HP didn't invent it, but we're trying to make it better. We're trying to extend it. And the idea is that in the future, instead of manufacturing being done in in fairly unpleasant environments around the world, they can be done automatically. You can have machines which have to be smarter so that they can design the things that we're going to need in the future. The design of products will be completely different than what we do now. Today, most things are done with injection molding or with subtractive manufacturing processes. 3D printing allows you to an additive process changes the way you create things. It also places severe demands on computation when these things are being built. The memory requirements for these sorts of machines is enormous. If you want to put texture on an object, it may sound trivial, but it's a lot of data to have every little bump specified. And so just the way that we look at encoding the description of objects is probably going to change. We'll have the ability for machines, for AI-powered computation, to create a whole new world. So this is an example of a bridge being constructed by robots. So you can imagine that one day robots will help us digitally be our arms, be our connection between computers and the physical world, which will allow computation to control our physical world directly, without our intervention. Another theme that we're looking at is edge compute. This is, probably most of you know what edge compute is. It's computing at the edge. When I was at Qualcomm, it meant computing in cell phones. At HP, we have a broader definition, which includes servers, on-premise data centers, etc. There's the idea that such devices will be more secure and more private. They'll use less energy. It seems insane that if you're going to gather data here, that you would send it hundreds of miles away for computation. That can't be power efficient. That's not how you would design a computer. So energy is going to be something critical for our future, and the way things are engineered right now, it doesn't computationally it doesn't make sense. So more and more things are going to be done at the edge. And I think that we're at the point in the not too distant future where the voice services, etc., are going to be right there at your home. You're not going to have to broadcast things far away. And so edge compute is something that we're interested in. We're studying in the Emerging Compute Lab, and we're looking at a particular form. We're interested in not only in laptops and servers, but also in the control of our cyber physical systems, a printer being one of those. Cyber physical is just a cool term for a machine which probably has some sort of actuation, has some sort of sensing, and you're allowing the AI to make very fast decisions, but you're still somehow monitoring it from the cloud. An example of this is we have these devices. This is called a web press. This is a tiny web press. This is a printer. Uses inkjet heads, and some of these devices are bigger than this room, I would say, and they can spew out print at acres per hour. And our challenge computationally is that these are digital printers. These are not analog printers. So every square inch of those acres and acres of print can be completely different. One can be a medical form, one can be a children's book, etc. We have the need to be able to inspect every square inch at high resolution in real time. And so you have paper streaming out 110 inches wide at about, I think, 16 feet per second or something like that. So it's a fun technical challenge. So here I am puzzling. How the heck am I going to make this work? I know I'll have her do it. Okay, so we have tremendous processing challenges. All this stuff takes power. You're familiar with the IBM Watson Jeopardy competition. So we had the winner 80,000 watts, the loser 20 watts. Okay, so it doesn't seem scalable that we're going to continue to create artificial intelligence using the conventional type of computing that we have today. It's just going to break the bank. If we want to build the future of tomorrow, we have to think about extremely low power computation. And one approach is of course neuromorphic computing, but we've also heard about a lot of interesting things here yesterday. I want to make a point about systems. This is a cat. He wants to eat. He has to maintain energy balance. So he has to go out and hunt occasionally to take energy in, but he doesn't want to use an excess of energy when he doesn't have to. He doesn't want to do more thinking than he has to. When you want to use energy selectively, and so at some point, I think there's a lesson I learned at Qualcomm is that you have to think in terms of, when you think of low energy, you can't think of low energy as a goal in itself. You can't think of high accuracy of your algorithms as a goal in yourself. You have to look at a balance in terms of creating a system. And so I think what's going to be interesting as a research topic going forward is how do we dynamically regulate in a continuous manner energy usage plus system accuracy to get a great and efficient balance. So this is an example of there is a cost of perfection. So I'm just going to leave you with this. disruptive technologies are not always obvious. Um, so, so the stuff that we're talking about here, people may say, well, what does this have to do with my laptop today? We'll never need DNA computing. I don't know. But throughout history, there's always been skeptics at when they look upon disruptive technologies. And so we shouldn't really be discouraged if everyone doesn't see things our way initially, but we should continue to look towards the future. So I'll leave you with this last quote.
Thanks. A couple of quick questions. Anybody got anything there?
What is the definition of AI from HP's perspective? I hear this term a lot. Are you referring to deep learning, deep neural networks only, or is more general?
That's a good question. So today, right now my lab is focused mostly on deep learning and exploiting deep learning, but tomorrow we could mean much more intelligent cognitive systems. And so we do have some background projects in systems which go beyond what we see today in deep learning. So yes, it's everything.
Okay, we have one more question at the back there. Just wait for a sec for the microphone.
Do you foresee any recycling issues associated with these developments? I mean, for example, if we think about packaging, there are already issues of recycling plastic.
Mm-hmm.
If one starts to put thin film computers on household goods, isn't that going to cause a recycling nightmare?
I think that's a good point. And one of the issues we're trying to address is sustainability. And so we're looking at not only how to build items, but how to decommission items and take them apart in an ecologically friendly way. So that's something on the horizon. I can't promise we know how to do it today, but it's something that's in our mind.
Okay, thanks very much.